Hi, in this video we're going to go over how to graph. So what I have here are the graphs from your exams. All of the graphs that I put on the exams are on this PDF, and we're going to go over each one. So your first exam started with a absolute value graph, and the first thing to know when you're graphing is what you're looking at. So the absolute values here and there tell me that it will look like a V. It's a good idea to have some sort of visual of what your object should be when you start graphing, because if you don't, have any idea that this side will go down and that side will go up, you'll spend a lot of time filling out points to be able to get a general idea of what the picture looks like. So it's really good to know what it would look like before you start. Okay, so to do this, I'm going to start with my XY table. X and Y. Similar to a function, this is going to be input and output. Or you could say, I will choose values. Oops, I'll choose right. Choose values and get values. Okay, so what values should I choose? Well, I'm going to start with just an XY plane in here. We're going to say this is the x-axis and this is the y-axis. Whatever values I choose should fit on this picture. So let me count these little dots. Zoom in. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I definitely shouldn't pick values that are above or below positive and negative 9. I want to see what it looks like on either side of the y-axis. And I've got some shifting that's happening. Usually when the number is in with the x, then it's shifting related to x, and when it's outside, it's shifting related to y, or in this case, g of x. The -2 is going to make us fat or skinny and tall, depending on how we interpret it. So if I have a -2 times an x value, that means every time I put in an x, f of x will be twice as large, or in this case, twice as small. So it's going up real fast, so I should get a big skinny one, because every time I move out 1 here, I'll go up 2. And if it was the opposite, if it had been like -1/2 times x, then every time I move out here, I only go up 1/2. So I'd have a big, fat graph. Okay, so now that I got a general idea of sort of what I'm looking at and what to expect from the graph, I'll go pick some values. Since I'm not shifting anywhere for x, that means I should still be hanging out around the origin, and y is changing, so I'm going to pick a value by the origin and then either side just to get the beginning values. So I'll choose -1, 0, and 1. Now what do I do with those? What I do with those is plug them into not y, we're beyond y now when we started calling it f of x, the output of the function. So I take my value and I plug it into the function. So -2 times the absolute value of 1, -1, plus 3. So the absolute value will make that a positive, so I have -2 plus 3, so I should have a positive 1. Let's see, if I put in 0, I get -2 times the absolute value of 0 plus 3, so that should give me a 3. If I put in 1, since I'm taking the absolute value, I should get the exact same result as I did with -1. The absolute value is just going to make it positive either way, so I would still get -2 plus 3, which is still a positive 1. So that means, I can go over here and erase my dots, put my axes back in. I'm just trying to eyeball cutting this in half. Okay. That's not really in half, but it doesn't really matter as long as I have an x and y axis that are about in the middle. This is x and this is y. Okay, so let's go put on our points. Use a bright green. I have a point at x equals 1 and f of x -1 and 1. So that point would look like -1, comma 1, for the x and the y. Here I have 0, 3, and here I have 1, 1. All right, so I'm going to go put those points on the graph. -1, 1, so back 1 and down 1. Oops, -1, +1. That's what I get for not being able to see my point. There we go. So -1, back 1, +1, up 1. Okay, here I have 0, so I don't move, and then up 3. 1, 2, 3. And here I have 1, 1, so positive direction 1, positive direction 1. All right, I just drew a bunch of V's to describe this, and now that doesn't look like a V. So let's, before we panic, go back to our original graph and we can see a negative. The negative in front of my coefficient is just going to flip my V upside down. So instead of having this drawing, I should have this drawing because of the negative. So that makes sense for my picture. So it looks like I'll have a graph that does that. I can always add more points if I feel iffy, I'm not sure that that's what will happen. I could go over. Let me look at -2 and +2 just to see what happens. That would be -2 times the absolute value of -2 plus 3 equals, let's see, -2 absolute value is +2 times -2 will give me -4 plus 3 will give me -1. And I should get the exact same value for +2 because of the absolute value. So it looks like at -2, back 1, 2, I should be at -1. Wrong color. And at +2, 1, 2, I should be down -1 as well. All right, so that gives me more of a V to work with, and what I want to do is a V. It looks like that. Well, I can do better than that. Hold on. There we go. Sort of. Let's make that dot real big. So what I'm going for is that you have a general idea of what these look like, and that's why I ask you to make tables or to label points so that even if you're not the world's best artist, I can tell whether or not your drawing is accurate. Just by checking a few of your points and making sure that your table has the right values in it. And then what I'm looking for over here is that the general picture is correct. You went up and then you went down and you have a V shape and you have straight lines and you're showing me that the graph continues to go on. All right, let's do the next one. Okay, so here we need to graph a cubed root function, and that should be kind of our swishy looking function. So a square root function should give us a parabola, or sorry, the half of the parabola that's positive. A squared function should give us a parabola, and a square root or a cubed root function should give us some sort of swish shape. So cubed root multiplied by 2, which means that it should be growing quickly, and move down 1 on y. Our domain in interval notation, since it's a cubed root, we don't run into any issues with negatives, so our domain would just be everyone. So we have lots of ways to write that. We can say all real numbers. We can say the fancy R that means all real numbers. That's what that fancy R means. Or we can say -infinity to +infinity. All those mean the same thing. Okay, we need an x and an f of x. We're going to plug into this table, but let's talk about values that we should try to choose first. So I have to work with a cubed root, which means that I should just not pick values willy-nilly. I need to make sure my values work well with a cubed root. For example, if I pick 2, then I've got to deal with the cubed root of 2, and I don't know what that is. So what if I pick 1? Well, the cubed root of 1 is just the number that I can multiply 3 times to get 1. So it's just 1. Let's see, what other little cubes do I have to work with? I think the next smallest cube would be 8. And I would multiply 2 times 2 times 2. This would give me 4 times 2, and that would give me 8. So the cubed root is 2. And another small cubed root would be 0. 0 times 0 times 0 is still 0. So that would be 0. So now that I have some cubed roots that are small, because they'll fit on this graph that goes from -10 to +10, and they're perfect cubes, so they'll work well in this function, I can start plugging and chugging. So cubed root means that I can use positive and negative. So all of these points have given me positive and negative points except for 0, which is neither positive nor negative. We'll go -2, -1, 0, 1, 2, just keep them in order. And let's look at the values I get back. Sorry, there should have been the cubes. This is -8 to give me -2, and +8 to give me +2. Alright, so I'm going to plug in -8. Plug in -8 into the cubed root, 2 times the cubed root of -8 minus 1. That will give me 2 times -2, because I have a -8, minus 1. And that should give me, let's see, 2 times -2 is -4, minus 1 is -5. Doing the same thing here, 2 times the cubed root of -1 minus 1. That should give me 2 times -1 minus 1. So that's, let's see, -3. 0, 2 times the cubed root of 0 minus 1. That should just give me -1. And here I have 1. So I would get 2 times the cubed root of +1 minus 1. That should give me 2 minus 1. That should give me 1. And 8, I should get cubed root of +8 minus 1. That'll give me +2. And that will give me 4 minus 1 is +3. Yeah, it's really hard to see. I'm using a big fat pen. It would have been easier on the exam to see what you were doing. But let's go ahead and make the XY points so that I can see what I'm doing. So I've got 5 XY points, -8, 1, 0, 1, and 8. And on the other side of the comma, I'm going to gather these numbers. I've got -5, -3, -1, 1, and 3. Alright, so now I'm going to go fill in those points. I'm going to learn my lesson from last time and make sure that I can see the points while I'm filling them in. Okay, so -8 and -5. I'm going to go to -8 on the x-axis and -5 on the y. And put a point right there. -1, -3. I'm going to go to -1 here and -3 on the y. I have 1, -0. Or sorry, 0, -1, 0, and then -1. Okay, I have 1, 1. And I have 8, 3. There's a couple things I can check for to make sure that I'm on the right page. 1 is that the general shape is the swish shape that I wanted. 2 is that there's symmetry between the distance between these 2 points and the distance between these 2 points. Okay, and I can also check for symmetry right here between these points, just to make sure. Sometimes when we write down our points, we might have accidentally written this one off a little bit, and then we should be able to tell that, oh, that doesn't quite look the same. Maybe I better double check one of those. So that was supposed to be 8, 3, 1, 2, 3. Okay, and my last step would just be to connect the dots. Woo. Okay. And I can go back and label some of these. This is 1, 1. What I like to do is label them without looking at the points. Let's hide those. This is 8, 3. And this is 0, -1. This is -1, -3. And this is -8, -5. And that I can double check those and make sure that when I just looked at the graph, I got the same points back. And I did. All right, let's try the next handful. This is from your test 4. But what looks like a circle, x squared plus y squared equals r squared. But this circle has coefficients next to x and y, and I don't want that for a circle. So I'm going to divide everybody by 10. So that I have this format. So I'll have x squared plus y squared equals 100 divided by 10 is 10. That means I have a circle that's not moved around because there's no addition and subtraction happening with y and x. And my radius is the square root of 10. The square root of 10 is not a pretty number to work with, but it is what it is, so let's try it. Let's try and approximate it in a calculator. Calculator. All right, 10 square root. So 0.16. Yeah, that's a good approximation. Okay, now I know that I'm going to have a circle and that it's going to hit somewhere between 3 and 4, closer to 3. 1, 2, 3. Right there. And 1, 2, 3. There. 1, 2, 3. Right there. And 1, 2, 3. Right there. Now all I have to do is draw a circle, which is way harder than it sounds. Ah, kind of like that. Let me see if I can make that better. Doesn't look like it, not in the computer that I was trying to circle. Alright, I can just tell you were trying to draw a circle. Alright, and the last thing I need to do is fill out some of these points. So, what do we have? I know that I-wax is here and here. I know that there's nothing in the middle. So let's try some values. At x equals 0, I should get x squared plus y squared is equal to 10. So at x equals 0, I should get essentially y squared is equal to 10. So y is equal to or minus 10. It gave me 2 square root. And it's also negative 10 square root. This is unusual for us to have two values in the domain that go to two values in the range, because this function does not pass the vertical line test. It's not actually a function. Okay, we need another point, so let's try 1. So if x is equal to 1, and 1 squared is still just 1, then y would be equal to 10 minus 1, and y would actually be equal to the square root of 9, which is better known as 3. So 1 will give me plus and minus 3, and also positive 3. And now I have some points that I can kind of double check. Let's see, over at 1, I should be up right about to 3. And at negative 1, I should be right about at 3. Oh, sorry, at positive 1, I should be at 3 and also negative 3. At 0, I should be at negative and positive square root of 10, which is what I was shooting for when I got this. So that graph is complete. Let's try the next one. Now I've got a parabola. There's some things about that parabola, and that is x and y are reversed. So this parabola will be sideways. I've got some shifting inside with the y, so it'll move this way and that way. Sorry, this way and that way. And I've got some shifting outside with the x, so it'll also move this way and that way. Let's try some points to make this a lot easier. Okay, let's see. Let's try some values of y. So since I want to pick values of y and get values of x. Let's choose some small values of y because we only go up to 10 and negative 10 on this. So let's just see what happens around the origin. Let's do negative 1, 0, and 1. So if I plug in x is equal to negative, open parentheses, and we'll do negative 1 for y, minus 4 squared minus 1. This is our y value. Then I get, let's see, 5 squared, so negative 25 minus 1. Oh boy, that's a big value. Okay, so that'll give me negative 26, which I can't even fit on my picture. So maybe we should take a minute and look at what this parabola is telling us. Let's focus more on where the shift is happening. I know I'll have a sideways parabola. It'll be facing the negative direction because of that negative in front. So something like this. It's going to be shifted, the opposite sign, up 4. And it's going to be shifted, the correct sign, negative 1. Okay, so that means that I'll have a sideways facing parabola with a vertex of -1, 4. So let's zoom in and let's add that vertex. -1, +4, right there. And we'll just add a shape of a general, I know that will happen. Okay, well that tells me -1 will end up giving me some point that's down here, and I won't get out there for a long time. So I better pick something else besides these values. 0 won't give me anything for a while as well, and 1 won't give me anything until I get out there as well. So let's pick values closer to the vertex. Let's surround the whiteboard. Okay, this is essentially like surrounding on our origin in a function that's centered at the origin. The center of our function is here. So we're going to pick values around that center. Let's go back and erase this work and replace it with our values at the center. I'll take that vertex and label it prettily so we can tell what it is. The vertex is at -1, 4. And let's try y is 5. Well, if y equals 5, that gives us x is equal to -5 or +5 minus 4 squared minus 1. Say 1 squared, which is 1, minus 4 is 0. Okay, so that's what we're doing, that we're getting the correct values. So x is equal to -4 minus 4 squared minus 1. These will give me 0. So -0 still doesn't matter. Now I'll go directly to -1 like we hoped it would. And let's try y is equal to 3. And that will give me okay, before we graph these, I'm sure you at home are yelling at me that this 0 is wrong. I get 5 minus 4, which is 1 squared, times -1 plus -1 gives me a -2. And the same thing here, 1 with a negative in front minus 1 still gives me a -2. So now that we've fixed those two, whoopsies, I've got a -2 and a -2. And before I move on, let's talk about how I knew that was wrong without actually checking on a calculator, is because I already said that my graph's facing this way, and getting values of 5 and 0, and then 5 and 0 again, didn't make any sense for me. So I went back and double checked my algebra. So let's see, I get 5 and -2. So there's -1, -2. And I get 3 and -2. So 1, 2, 3, and -2. I can do points. I can put on the side 6 and 2, just to make sure I've got a full picture. But all that I'm required to do is 3 points, and that does give me a good idea of what's happening with the graph. So we'll just add the parabola from there. And say it's headed that way. Here are 3 points, and here is our vertex. Alright, let's do that one last time. We've got how we're used to saying notice function notation. It'll pass that vertical line test. When our parabola is side to side, we do not pass the vertical line test. It's not actually a function. I'll erase that later. The computer's having a hard time how long this video is. Okay. So let's talk about the vertex. Where am I going to be shifted? So inside is going to shift the variable next to it, and it's going to do it in the opposite direction of what you're seeing here. So that'll mean I moved that way 6. And outside is going to move the variable on the outside, and it's going to move it the same as the sign you're seeing in here. So I'm going to be this way 3. That means my vertex will be at 6, 3. I don't have anybody negative in front, so that means it'll just be a regular happy face. Since I know that the vertex is at 6, 3, let me draw that on my graph. 6, 1, 2, 3. I want to try and pick points around that vertex, around the 0 for this graph. So I will choose 7, oops, it's a regular graph, 7, 6, and 5, and I'll find points for these. So if x is equal to 7, and we get 7 minus 6 squared, I'll be more careful with this algebra this time, that 1 minus 8 and 2. So this is negative 2. Making sure that our value of 6 works how we expect it to. 6 should give me 6 minus 6 squared minus 3. And that will give me negative 3. Okay, and let's see. Plugging in our value of 5, we have 5 minus 6 squared minus 3. That will give us negative 1 squared, which will go back to positive 1, minus 3, and that'll give me a negative 2 once again. Negative 2. So, adding my points. 6, negative 3. Oh boy, sorry. I said we go the same direction as the sign here, and then I drew the arrow the wrong way. So our direction should match the sign. And then the inside, our direction should be opposite. All right, so that means that's negative 3. And, oh good, good thing we checked that point. Always helps to make sure. Okay, so let's go add these points to our graph. 6 minus 3. Positive 6, 1, 2, 3, 4, 5, 6. And then minus 3, 1, 2, 3. 7, one more. And then minus 2, 1, 2. And 5. And then minus 2, 1, 2. All right, so we have a parabola. Yeah, it looks like a happy face. All right, I hope that helped. Sorry there were so many mistakes in it, but it's a half-an-hour long video and I don't have the ability to edit. So hopefully the mistakes helped you identify things that can go wrong while you're doing this, and also ways to check to make sure that it's going right as you go. So that would be why we have this, as well as identifying the vertex separately so that we can double check what we're doing as we go.